Okay, good day. This is Math 130 Intro to Statistics. I'm Professor McCulley. This is lesson number 13, Probability Distributions. Let's get right to it. So, today we're going to distinguish between discrete random variables and continuous random variables. We're going to construct a graph, or construct and graph discrete probability distribution and determine if a distribution is a probability distribution. We're going to find the mean, variance, and standard deviation of a discrete probability distribution, and we're going to find the expected value of a discrete probability distribution. So the first thing we need to do is make some definitions. The first one is a random variable. A random variable x represents a numerical value associated with each outcome of a probability experiment. Random variables can be either A, discrete, when it is discrete, when it has a finite or countable number of possible outcomes that can be listed. It is continuous when it has an uncountable number of possible outcomes that have to be represented on an interval in a number line. So example, label the following as defining a continuous random variable or a discrete random variable. So let x represent the speed of your car. Well, the speed can be divided up into smaller and smaller things and can't necessarily be counted. So this one's going to be continuous. Let x represent the number of cars produced in a given year. Well, the number of cars can't be divided into portions. You can't have a half a car. So that's going to be discrete. Let x represent the number of marbles in a jar. And again, you can't have a half a marble, so this one's going to be discrete. And let x represent the volume of water in a jar. Now you can cut your volumes because water can be cut into smaller and smaller individual pieces. It's uncountable, so we're going to call that continuous. All right, moving on. Definition: a discrete probability distribution lists each possible value the random variable can assume together with its probability. A discrete probability distribution must satisfy the two following conditions. So number one, the probability of each value for the discrete random variable is between 0 and 1 inclusive, and the sum of all of the probabilities is 1. And so we've done some distributions before in tables, and that's what this is going to look like. And so we're going to have the outcomes in one column, and then we're going to have the probabilities in another outcome. And then as a check, we'll add up all the probabilities and make sure that it's 1. All right, so here's our guidelines. Let x be a random variable with possible outcomes, x1, x2, x3, so forth, and xn. Make a frequency distribution for all the possible outcomes. Find the sum of the frequencies. Then we're going to find the probability of each possible outcome by dividing its frequency by the sum of the frequency. And then we're going to check that each probability is between it should be 0 and 1 inclusive, and that the sum of all the probabilities is 1. So we need a 0 right here between 0 and 1. So let's do an example. At a local pub quiz, 20 tables of 4 people were asked a simple trivia question. Each table counted the number of correct answers, then the scores were taken, and the following frequency distribution was created. So a score of 0 means that there was one of the 20 tables where nobody got the question right. There were 4 tables where one person got the question right. There were 6 tables where 2 people got the question right. There were 7 tables where 3 people got the question right. And there were 2 tables where all 4 of the people got the question right. So the first thing we want to do is we are going to create a probability distribution here. So let's make a table. Let's see, I've got 6 things there. Yeah, 6. So let's go 3. I think we're going to go 3 by 6. I'll move this down here underneath. We may not need to do all of those, but we'll start there. All right, so we're going to start with score here. Then we're going to do frequency. and then we'll do probability. All right, so we've got 0, 1, 2, 3, 4. We've got 1. Let's see, the second one was 4, 6, 7, and then 2. And then let's see here, this is going to be the probability. So the probability, first we should add these to make sure. 1 and 4 is 5. 5 and 6 is 11. 11 and 7 is 18. 18 and 2 is 20. So the probability for this one will be 1 out of 20, which is 0.05. The probability for the second one will be 4 over 20. I don't know why I have 5 there. 4 over 20, which if you put in your calculator is 0.2. 6 out of 20 is 0.3. 7 out of 20 becomes 0.35. And then 2 out of 20 is 1, or 0.1. Now, to make sure that, so our final probability distribution will look like, let's add another table here, and we're going to add a 7th column, or 7th row. Come back down here. And so we have the score, and we'll have the probability. Let's shrink this up a little bit. It takes a little too much room. Ah, you stink. There we go. All right, so, and I want that going there. Okay. Ooh, that was weird. All right, so 0, 1, 2, 3, and then 4, and then the probability. Let's see, we got 0.05. We had 0.2, 0.3, 0.35, and 0.1, the probability of X occurring. And then just to be on the safe side, just to make sure that we're all right here, the sum of P of X, let's see here, 0.5 plus 0.2 is 0.25, plus 3 would be 0.55, plus 0.35 would be 0.9, plus 0.1 is 1. So this is our discrete probability distribution. All right. And then moving on, the mean of a discrete random variable. The mean of a discrete random variable is given by, the mean is the sum of the x values times the probabilities of each of those. So each of the x is multiplied by its corresponding probability, and the products are added. And then the expected value of a random variable, the expected value of a random variable is equal to the mean of the random variable. So the mean of the random variable and its expected value are the same things. So as a continuing example here, we are going to find the mean of the discrete random variable found in the pub quiz that we just had. So oops, I didn't want to do that. Let's hit the table. I want to insert a table here, and let's go 3 by 6, I think. 3 by 7. There we go. All right, and so from the last one, we've got our score here. We have, and that is our x value, 0, 1, 2, 3, and 4. Then we had our P of X, our probability of X was 0.05. It was 0.2, 0.3, 0.35, and then 0.1. And then the sum of those probabilities of X we found to be 1. And so X times the probability of X is just me multiplying these two. So 0 times 0.05 is 0. 1 times 0.2 is 0.2. 2 times 0.3 is 0.6. 3 times 0.35 is 1.05. And then 4 times 0.1 is 0.4, and so the sum of the x values times the probability, so this notation just says sum all these values up, gives me 2.25. So that is my mean of the discrete random variable. That's what I was looking for. Now, since the mean and the expected value of this is the same thing, we can interpret the expected value to be in terms of the units. Probability is just the probability that it's coming out, but the score is the number of correct answers in this case. So the expected value is the value that you would, let's make that a better you, would expect to get if you played the game. And so in this case, if a table was chosen at random, we would expect for these players to get 2.25 questions correct. And we can do that with a number of different things. Okay, so the variance and standard deviation of a discrete random variable. The variance of a discrete random variable is going to be the sum of the variances squared times the probability. And just like in previous instances, the standard deviation is just going to be the square root of the variance. So this is a little bit different. And so we want to, as our last example, we want to find the variance and the standard deviation of the pub quiz example. So again, let's see here. I need another table. We're going to make this again a 3x7. I think will fit. All right, and so I have the score. I have the score, which is x. I have my probability of x. So 0, 1, 2, 3, and 4. And then we had 0.05, 0.2, 0.3, 0.35, and 0.1. And remember, the sum of the probabilities was 1. And so now we want to find that variance times the probability squared. So that probability x. And so in this case, it'll be 0 minus 2.25 quantity squared times 0.05, and that turns out to be 0.2531, and then 1 minus 2.25 quantity squared times 0.2, that turns out to be 0.3125, and then 2 minus 2.25 squared times 0.3, that turns out to be 0.1875, and then 3 minus 2.25 quantity squared times 0.35 is 0.1969, and then 4 minus 2.25 squared times 0.1 turns out to be 0.3625, and so the variance, that squared, is equal to the sum of these deviations, x minus the mean squared times the probability of x. And so if I add all of these values up here, I get 1.0875. And so that is my variance. And squared equals 1.0875. And if I take the square root of that, my standard deviation, the square root of the variance, which is the square root of 1.0875, and that turns out to be, if you put it in your calculator, 1.0428. Now we can simplify that process a little bit by doing the one variable stats. If I grab my graphing calculator here and I go stat, we want to clear out the list because we don't know what idiot used it before. And we go second L1, second L2. Oops, I need a comma in there. Apologize for that. And so if we go, let's see here, stat, edit, in that first list we want the scores. So 1, 0, 1, 2, 3, and then 4. And then if we go over to here and we go put 0.05, 0.2, 0.3, 0.35, and then 0.1 there. And we go stat, we go over to calculate, we do first variable stats. Now, the default position is not to have a frequency list. So our probabilities are our frequency list. And so we're going to hit enter in there. And we can see that the standard deviation 1.0428, that is what we got right there. And we could calculate the variance by squaring the standard deviation, which is a little bit backwards, but that's okay. All right, that's all I got for today, folks. So, Marvel fun fact of the day: Paul Bettany plays the voice of Jarvis in all of the Iron Man movies until Avengers: Age of Ultron, when he becomes the Vision. Until that point, Mr. Bettany had never met any of the other cast members. He was only a voice-over actor. You guys have a great day. Goodbye.